Here we'll deal with another type of combination which is called a composite function. I've asked you to find g with a little circle in the middle and then f of x. The little circle in the middle stands for composite. A composite function can also be written with a letter, then a parenthesis, and then a second letter followed by x. If you see this configuration with two letters next to each other and a parenthesis in the middle, that also means composite. Now, in short, to do a composite function means to place one function inside of another function. For this question, you can see we have g composite f. We are going to start with the first letter in that chain, that's g. And we'll write down that function first. Once we've written that down, we will now place the f function everywhere we see x. So notice that gx has an x and then a -4. We're going to change that x. To show that we're about to change that x, we're going to replace that x with a parenthesis. We'll just write the same thing over again, but put a parenthesis before the -4 rather than x. Then we look to the second letter after the composite symbol. The second letter after the composite symbol is f. So that means we're going to take function f and place that inside the parentheses where the x once was. That is, we are always going to exchange x for whatever the second function is. G was the first function, f was the second, and so the f function will go in the parentheses where I've drawn this arrow, and that is 2x minus 3. So we'll now have square root of 2x minus 3 minus 4. However, we can combine the like terms. We'll have a -3 and a -4, and together that makes -7. And so our new composite function is 2x minus 7. We'll write that as g composite fx. This is to show we started with g, but we replaced x with the letter f, which is 2x minus 3. However, when we simplified it, we ended up with 2x minus 7. Now that we have our new composite function, we can find its domain as well on the next slide. To find the domain of a composite function, we have to begin by finding the domain of the second letter function. This means we're going to start by finding the domain of fx because that is the second letter. The reason we do this is because if fx is undefined, the entire composite is also undefined. So if we look for the domain of f, that is going to exclude certain areas of our number line. Because if f's undefined, the whole thing's undefined. So we're going to look at the domain of fx first. Now let's recall that there are three things we're looking for when we're dealing with domain. We're looking for square roots because anytime you have a square root, the inside must be greater than or equal to 0. We're also looking for denominators because inside the denominator of a fraction, the bottom must be not equal to 0. We're also looking for logs or ln's. If you have a log or an ln, those must be strictly greater than 0 inside. However, fx is just 2x minus 3. And that 2x minus 3 itself does not have a root or denominator or log. Our new composite function does, but we're only examining f right now. This means that we have no restrictions on our domain from the f function. Ordinarily, we would write this as -infinity, infinity, but we won't do that just yet because we may have some restrictions from our new composite function. We'll begin by drawing a number line, but keep in mind that from the f function, we have no restrictions, and so that'll be -infinity to infinity. But now that we've seen that, let's examine the domain of our new composite function. Our new composite function is square root of 2x minus 7. Because we have a square root, the inside of that must be greater than or equal to 0. Therefore, when we look at the domain of the composite, we're going to have to say that the 2x minus 7 must be greater than or equal to 0. To solve this, we'll add 7 to both sides, and we'll get 2x is greater than or equal to 7. When we divide both sides by 2, we'll get x is greater than or equal to 7/2. And remind ourselves that greater than or equal to means this is going to have to be a closed dot, and we're going to shade to the right because of the greater than. Therefore, we'll place that closed dot at 7/2, we'll shade to the right, and see that we'll have 7/2 to infinity for our domain. The infinity will be parentheses, and because of the closed dot, we will have a square bracket on the 7/2. Ordinarily, at this point, we would examine where the domains intersect, but one of our domains had no restrictions, so that won't be necessary this time. But in a future video, we'll do an example where we'll have to check for that because we'll have restrictions from both domains. But for now, in this problem, our domain is 7/2 to infinity.